Walk down any grocery store aisle, and you'll find raspberry flavor in everything from yogurt to cookies. You might assume this variety reflects the vast botanical diversity of the Rupus genus, which actually contains over 500 distinct wild species in nature. This visualization shows a massive discrepancy between nature and the supermarket. Out of those 500 natural species, a single cultivar developed in 1967, known as the Meeker, accounts for an overwhelming majority of the global processed food market. The United States imports over 90% of the frozen raspberries it consumes domestically from countries like Chile and Serbia. Despite crossing thousands of miles of ocean, those global supply chains all rigidly conform to growing this exact same variety. While consumers walk past aisles of options, the agricultural reality is remarkably narrow. Despite a world of 500 wild species, nearly every label traces back to this single, specific industrial blueprint. To see what the industry left behind, look at the varieties farmers actually sidelined. The yellow Ann raspberry, for example, develops an unusually sweet, apricot-like flavor profile that standard commercial red berries never reach. Then there is the black raspberry. It consistently registers the highest antioxidant content of any berry ever measured. Because of these phytochemicals, researchers are studying black raspberries for anti-cancer properties. Yet this fruit remains marginalized in the commercial produce sector. If the food industry were optimizing its supply chain for human health or for maximum flavor, the Meeker would have been replaced decades ago. The fact that it dominates suggests a hidden mechanical requirement is driving global agricultural adoption. That requirement is physical survival. A fresh berry has to endure a journey from a distant farm into an industrial freezer, a logistical gauntlet known as the cold chain, which serves as a strict physical filter for our grocery infrastructure. When you freeze a premium, highly flavorful raspberry like the Tulameen, water expands inside the fruit. Jagged ice crystals form, violently puncturing and tearing through the delicate cellular walls of the berry. Once that berry thaws at a processing plant, those punctured cells inevitably collapse. The highly prized fruit turns into an unusable, watery mush that physically jams up factory machinery. This is exactly the problem the Meeker was designed to solve. Agricultural scientists bred it in Washington state in 1967 specifically to survive this kind of thermodynamic trauma. This comparison shows the Meeker's primary defense mechanism. While a standard raspberry collapses into a puddle after a freeze-thaw cycle, the Meeker has uniquely firm flesh that maintains its geometric shape and structural integrity. It also reliably holds a bright, uniform red color, perfectly matching the baseline expectation a consumer has when they open a processed fruit product. The Meeker was never bred for someone to eat fresh off the bush. It was engineered to survive industrial processing and still visually pass as a recognizable raspberry when it comes out the other side. American food manufacturers quickly realized the value of this durability and adopted the Meeker's unique physical properties as their absolute baseline metric for processing. Millions of dollars in factory machinery, highly specific freezing protocols, and processed product formulations were permanently calibrated to handle this exact berry's firmness, shape, and water content. This strict standardization inside American factories forced a shift in global production. To keep their contracts, massive agricultural sectors in Chile and Poland had to clear their fields and replant with a berry that met the American factory specification. This map tracks how that global supply chain operates today. To access the lucrative American manufacturing market, those foreign farms had no choice but to grow the exact variety that the machines demanded. Economists call this phenomenon technological lock-in, a scenario where a legacy standard becomes so deeply embedded in a system that replacing it with a better botanical alternative becomes too expensive and complex for the industry to justify. The Meeker's dominance is structural. Every link in the multinational frozen food chain, from the harvester to the shelf, was designed specifically to accommodate this berry's unique cellular resilience. But for some mass-market food manufacturers, even the highly durable Meeker introduces too much agricultural unpredictability. Their solution is to abandon the farm entirely. The scent and taste you associate with most mass-market candies, sodas, and candles comes from a single core chemical compound called raspberry ketone. This diagram breaks down the molecular structure of that compound. Extracting natural ketone requires hundreds of thousands of kilograms of fresh fruit for a single kilo of extract. So in the 1960s, the food industry bypassed this economic absurdity by synthesizing the exact same molecular structure from cheaper sources, like birch bark. When a consumer reads natural flavor on a mass-market product label, it often designates this perfectly synthesized molecule, completely disconnected from an actual berry field. The evolution from the durable Meeker to a synthetic ketone demonstrates how our modern food system prioritizes extreme supply chain consistency over the realities of nature. There is a stark contrast between the hidden, rigid mechanics of the global supply chain and the simple, everyday experience of opening a jar of jam or a container of yogurt in your kitchen. The produce that commands global agriculture is optimized for mechanical durability and long-distance transport, not for human joy or nutritional superiority. That spoonful of yogurt is a testament to industrial persistence. It is the taste of a fruit that survived the global journey, a berry that conquered the world because it was the only one that refused to fall apart.